Hello everyone. Today we're going to go ahead and learn how to solve trigonometric equations. So go ahead and pause the video and recall the 30, 60, 90 triangles. So from what we've seen these previous days, we've been able to simplify, we've been able to prove trigonometric functions. And we're probably thinking now, okay, how can I expand on this? Well, now we could actually find those theta for which we were simplifying. So one thing to know is that we should be familiar still with our degrees to radians, just like I have here. Pi over 4 is the same thing as 45, and 90 is pi over 2. Okay, so for 30 degrees, we have the length of 1. For 60 degrees, which is pi over 3, we have square root of 3, and for 90, we have 2. For square root of 45, we have 1, and for 90, we have the square root of 2. Any of these can be found by using the Pythagorean theorem. Okay, so let's go ahead and continue. Well, again, we at a glance, guys. This is our week before we go into our Thanksgiving break. So one more lesson and we'll be golden, right? I will be uploading videos during the break so we can start on our midterm review. Okay, for today, what we're going to go ahead and try to do is to try to solve trig functions, these two trig equations, sorry. Okay, something that I do need you guys to be aware of, and my mouse is stuck. That's weird. Super weird. Okay, something that I need you to be aware of is that we are still working with the unit circle, guys. This is not going to leave anytime soon. So please go ahead and pause the video, find those notes, or quickly write this down. So we do live in this digital age, so you can actually search for a unit circle image, right? But ideally, you should have most of these known, memorized, or know how to evaluate the unit circle. Okay, keep in mind, x's and y's are these coordinates right here, which is our cosine at that given angle and our sine distance at that given angle. And for tangent, don't forget that tangent is y over x. Okay. Something that I also need you to be aware of is the trig bow tie. So for the trig bow tie, friendly reminder, that is how we go ahead and draw these triangles on here. So if there was an angle, the terminal side would be at that angle in whatever quadrant it is. But what I need you to know is that, hey, the triangle is created with uh, the right angle is created at the x-axis. So be very, very careful when you actually do this, because I don't want you to go ahead and draw it incorrectly and then not be able to figure out the theta. Okay, and for reminder, the thetas are here closest to the origin, right? Okay, and for, friendly reminder also is for our all students take calculus. This is for everything here is positive. All 6 trig functions here, only sine and its reciprocal are positive. Everything else is negative. And for tangent, for t, tangent is positive. Cotangent is also positive. Everything else is negative. And last but not least, cosine and its reciprocal secant are positive. Everything else is negative. Okay. So let's go ahead and begin. So let me go ahead and hide my video and my panels here so I can get more space. So what I want you guys to think is find me the theta that creates the ratio of 1/2. So what angle evaluated at sine gives me 1/2. Okay, so refer back to our notes. We're thinking about SOHCAHTOA. And we're thinking, okay, sine is opposite over my hypotenuse. So in reality, I'm going to go ahead and draw a triangle that makes this true. So for sure, this is positive. 1/2 is 0.5. That is a positive number. And I have this right here, right? I have this triangle right here where my opposite side is 1, my hypotenuse is 2. Okay, so that is one solution, and I'm asking myself, what theta, right? What theta gives me that length of 1, right? We can look back at our notes from the 30, 60, 90 triangle, and we can see, oh snap, I know that that theta is 30 degrees, or pi over 6 radians. Now, my question to you, is that the only place where this is true? Is this the only triangle we can go ahead and draw on this paper? Well, we have this right here because of sine right here. Sine is also positive in this quadrant. And sorry, I don't draw these to scale. I noticed that in class also, like, oh snap, I'm way off. Okay, but not to scale. But let's say we have that same triangle, right? Theta's right here. Opposite is right here, positive 1, and my hypotenuse is 2. So the reference angle, right? This right here, 30 would be our reference angle. So this right here is still 30 degrees. Now, what I need you to know is we always measure triangles from the standard position. So from the x-axis, and we go ahead and see how much it is to here. So the degree from all the way over here. So if we know this is 180, our reference angle is 30, this right here has to be 150 degrees. Okay, so theta equals 150 degrees. Now, we've learned how to work with radians, which is this right here is pi, which is the same thing as 6 pi over 6. Think about it. This right here is a pi over 6, and I don't have the whole half circle. I am missing one slice of pi over 6. So think about a pizza that has 6 slices on top, and I'm missing one slice. I have a total of 5 of the 6 slices, so 5 pi over 6. Okay. So my question to you is, okay, we found this other triangle. Now, are these the entire solutions? Is this all the solutions for this when sine equals 1/2? Is that all the angles, 30 degrees and 150 degrees? Well, I'll let that sink in, but I want you to think about the concept of the unit circle, the circle in general. If we have this point right here, right, this terminal side right here, how long will it take, or what distance will it take in order for us to land at that same terminal side? Well, hopefully you are thinking that, oh snap, I'm sitting inside a circle, so therefore, if I do a whole 360, if I do a whole revolution, I will land in that same exact position, right? And you can think about it like a clock. I know we said in class, like the saying of like even a broken clock is right twice a day. Like I'm just saying that, hey, it's gonna go ahead and repeat, right? Now, how many times can it repeat? Well, think about it as the circle. Think about it as time, if you will. Time is gonna continue, so therefore we're gonna keep on landing on the same spot, right? 360 degrees, or the other direction, right? Oops, that was horrible. 360 degrees. So we said, well, I'm going to go ahead and pick radians because that's what you guys should be working with. This is 5 pi over 6. So these are indeed two solutions, two different solutions, right? Because if I go ahead and spin 360, it's not going to land on the other one. It's going to land right where it's at. So I have two. Now, in this case, what I need you to know is you need to account for the change, right? Which we just said was the period of sine, which is 2 pi plus 2 pi. Okay, because I can spin in the positive direction, but I can also spin in the negative direction. So I'm going to go ahead and account for that by saying this right here will be a variable z, and I'm going to go ahead and state what z is. Z is an integer, sorry. Okay, z is an integer. Okay, and what that means is it's a positive or negative whole number. Sorry, my handwriting is real bad today. So this right here is what we're saying. I know in class I put a plus minus, but I wasn't thinking. But ideally, it's the integer is accounting for the negative. So if z was -1, well, now I'm subtracting 2 pi. Hopefully that makes sense, right? Alrighty, so that's what we're gonna go ahead and learn today. So I have this meme for us. Usually in class, we've only found two solutions. I'm like, hey, Christina, that's it. Actually, guys, there's infinitely many solutions, right? Okay, so something that I want you guys to know is, hey, um, start off by drawing the triangle. Simplify the equation. Try to find that triangle. See where it lands. Then find what angles are created at that triangle, at that reference, and look for restrictions. Usually they will tell you like, hey, only from 0 to 2 pi. That's a restriction, guys. Or only from, let's say, from, I don't know, 0 to pi, or something like that. They'll tell you, be like, hey, only from here to here, and that's it. In this case, they did not. So that's why we added plus 2 pi z, where z is an integer, right? Keep in mind that's only for sines, cosines, right? And the reciprocals. If this was tangent, it would be just pi z. Oops, where z is an integer. Because the period of tangent is just pi. Okay, so let's go ahead and try some more. Something that really helped my students this year was like, hey, okay, I understand that sine, cosine look intimidating, but in reality, guys, you've seen stuff like this. You're still manipulating, let's say, this variable. You can do the substitution, if you will. And I use y because I think about sine. But ideally, solve for this. So pause the video, try to figure this out. So hopefully you start off by moving this y to the other side. So square root of 2 is equal to y plus y. So square root of 2 is equal to 2y. So from here, we can go ahead and divide by 2, divide by 2. So my y is equal to the square root of 2 over 2. Now, see how that was not that bad? This is probably an algebra 1 question, a two-step equation. Now, think about it if it was asked to you like this. Square root of 2 minus sine of theta is equal to sine of theta. You would do the same idea, and at the end of the day, you would get sine of theta is equal to the square root of 2 over 2. Okay? So that's what I want you guys to think about this. Okay, so as I mentioned, go ahead and give this one a try. So we have the same procedure. I'm going to go ahead and add sine to both sides. Okay, so I'm left with square root of 2 on my left hand side is equal to sine plus sine. So keep in mind, apple plus apple is just 2 apples, so it's 2 sine of x. Okay, now from here we can divide by 2, divide by 2. So we have sine of x is equal to square root of 2 over 2. Now, by now, guys, you should know well, I should have wrote a theta, but you should know a value of sine that gives you square root of 2 over 2. Like this should be something like a clockwork, right? We should be able to know that, hey, this is actually when x is equal to 45 degrees, right? If you need a visual, we can always draw it, which I strongly recommend, but I was just pointing it out that, hey, this right here, let's say this right here, this originally was square root of 2 over 2. And this one right here is square root of 2 also. But yeah, what I'm saying is like, hey, this should be something that you know. It's like, oh man, I know that it's pi over 4. Okay. Once again, is this the only place where this exists? Well, we said this was pi over 4. But as we noticed, these right here will happen at least twice throughout my unit circle. So the other place it lands for sine, maintaining true to its signs, like true to its positives or negatives. In case this is right here, this is positive, so my 2 is right here. This is my 2, and I once again my reference angle is pi over 4. However, I measure it from the standard position all the way to this right here, knowing that this is 4 pi over 4, right? And the top side of my unit circle, I have 4 slices I am missing, right? I am missing this one right here that I just found, this red one that I just filled in. So in reality, I only have the 1, the 2, the 3. I am missing the fourth slice. So I have that another solution for this would be 3 out of the 4 pies. Okay, so my solution should be x equals pi over 4 and x equals 3 pi over 4. Keep in mind, we're working with sine, and what is the period of sine? It takes an entire 360. It takes an entire 2 pi in order for this to repeat itself. So I'm going to go ahead and put the variable. Keep in mind, you do not have to put z like I did. You put w, t, whatever the case may be for it. So where z is a integer. Where z is an integer. Okay. So let's go ahead and try something a little bit tougher, but ideally this the same topic. So go ahead and pause the video, solve for x. So I'm gonna go ahead and add 1, add 1. So we have 3 tangent squared of x equals 1. I divide by 3 on both sides. I have tangent squared x is equal to 1/3. Dilemma, tangent is squared in this scenario, so how do we get rid of a square? We just do the square root. So tangent x is equal to the square root plus or minus, 1/3, which we know is the square root of 1/3, which is the same, over square root of 3, which is the plus or minus 1 divided by the square root of 3. Okay. Now, this one is going to be a little bit trickier. Okay. As much as I want to tell you, hey, this right here, it's going to be in quadrant 3. Unfortunately, what we need to know is that, hey, this right here is only going to be split up on the top side of the unit circle. So if we were to do this, we can see that, hey, my tangent, when I did my arc tangent from my previous unit, when I did arc tangent is equal to the arc tangent of plus minus 1 over the square root of 3. I was restricted to these two quadrants, quadrant 1 and quadrant 4, right? This is from our notes from the evaluating inverse trig. So ideally, what they want me to know is that, hey, I'm going to have one here, one in quadrant 1 for sure, without a doubt, because this fraction is positive for one scenario. Remember this right here. So I'm trying to find the 1 over square root of 3 scenario and the 1 over the negative 1 over square root of 3. So ideally, we should have another one right here. Okay. Now, so that's pretty much what we're going to go ahead and do. If we were to add pi to it, then this one would land right over here. What my students like to do is like, hey, they would just still graph it here for t, and then just reflect it to the s, to quadrant 2. Now, but just to teach it, just use what you knew about arctangent and evaluate here in quadrant 4. And keep in mind, if I was to add a pi, right, it would land in quadrant 2. And for this one, if I was to add a pi, it would land in quadrant 3. Okay, so from here, let's go ahead and solve for 1 real quick. So we have that this tangent's opposite is 1. Its adjacent is square root of 3. So my theta that gives me a 1 would be 30 degrees. So pi over 6 is one solution. Okay. Okay. Now, for my second solution, we can see that theta is right here, and my second triangle will be right over here. Okay. Or you could add pi and work with this one. Ideally, this one will give you the same solution, except that now this would be square root of 3. But keep in mind, this is still the angle that you're using is the theta here. So we can see that here it's still 30 degrees. This one is still 30 degrees. Now, this goes to the idea, guys, that tangent has a period of pi. So no matter what I do, if I add another one, if I add another one, it'll just keep bouncing from the green one will keep bouncing from 2 to 4, 2 to 4, 2 to 4, and the red one will bounce from period 1 to 4 and 1 to 3. And after I add pi and add pi and add pi, they will keep doing the same rotations. So for here, I would have to go ahead and add negative pi over 6, but my period is pi. So for both of them, it's pi. Now, in order for it to cover all the units, it would be at your value of z, where z is an integer. Okay, so ideally this would cover all the negatives, all the positive values for pi over 6 and negative pi over 6. Okay, so just to stamp the idea, why is there infinite many solutions? Well, that goes back to the circle, guys. If we have a circle and I give you a point on this circle, you can go 360 degrees clockwise, 360 degrees counterclockwise, and ideally you land in that same position. Okay. Alrighty. For the homework, guys, I went ahead and gave you guys three questions. I will be available during Power Hour to help you guys out in to clarify some of the stuff. But I will try to make some videos on how to solve them as well. Okay. As always, guys, it has been a pleasure and thank you. I believe I took too long in this video, but thank you for sticking by. Awesome. Thank you, guys, and bye-bye.